Welcome back. We're covering section 1.3, collinearity, betweenness, and assumptions today. We're going to start off with the definition of collinearity and show a quick example of what is collinear and what is not. Collinear points are points that lie on the same line. Usually we're going to talk about more than 2 points. Non-collinear points are points that do not lie on the same line. So we're looking at these two diagrams and trying to figure out if A, B, and C are collinear. So if we look at the first diagram, it should be pretty clear that all 3 points A, B, and C are all part of the same segment. If we extend a segment, we get a line. So yes, they will be collinear. The second one, however, points A and B are definitely collinear, and actually if we grab any 2 points, they'll be collinear, but all 3 are not part of the same line. In fact, they're going to form a triangle. Anytime you have just 2 points, they will always be collinear. You can always make a line out of 2 points. Betweenness. Betweenness occurs when one point is between 2 others. But in order for that to happen, all 3 of the points, or 4 points, or whatever you have, must be collinear. They must be on the same line. So we want to know if S is between R and T. Well, in the first one, yes, it is, because they're all part of the same line. So S is to the right of R and to the left of T. So yes, it is between R and T. But for the second one, it's not, because R, S, and T are not part of the same line. Alright, now we're going to talk about assumptions from diagrams, things that we can assume just from looking at the picture. There are 4 main things that we can assume. We can assume straight lines and angles. We can assume collinearity. Points look like they're on the same line, they are. We can assume betweenness, which means one point is between 2 others. And we can assume relative position. W is to the right of X. Similar statements. Now, what can't we assume? And this actually is more important, because a lot of times we make assumptions that aren't true. We cannot assume that we have right angles. Now, there's a difference between an assumption of a right angle and knowing it's a right angle. If we have a little box in the corner of the right angle, they're telling us it's a right angle, as opposed to an assumption. We cannot assume congruent angles. If they look to be the same, doesn't mean that they are. We have to have more information. Maybe they're vertical angles and they are actually congruent, but we don't know that on first appearances necessarily. We cannot assume congruent segments. You don't know that segments measure the same thing. Without actually measuring it, we're not going to do that. We won't know they're congruent unless we have more information. And really, the size of any angles or segments, we're not going to assume that at all. We're not going to assume that something's acute because it looks like it. So we're looking at this diagram. We want to know what can we assume and what can't we assume. Now, of the assumptions that we could possibly make, some are helpful and some are not so much. So probably the most helpful thing for us to be able to do is assume that we have a straight angle. So maybe we're going to say that angle BCE is a straight angle. That's a fair assumption. We could also maybe assume that B, C, and E are collinear. And maybe we're going to assume that C is between A and D. And any similar statements that we can make. Of those assumptions that we made, the only one that's going to be really helpful to us is that one right there. BCE is a straight angle. We're going to later on in section 4, when we begin proofs, talk about straight angles and the relationship between them. Now, talking about things that we can't assume, there's a lot. Maybe we can, based on appearances, assume that E is a right angle, but that's not a fair assumption. We don't know for sure. We don't know what it is. So angle E is a right angle is a bad assumption. Maybe we're going to assume that DE is congruent to AB. Looks like it, but I don't know that it is. Maybe we're going to assume that angle A is congruent to angle D. Again, without more information, that's a bad assumption. So we have to be extremely careful about what we assume. Alright, now in this example we have a diagram given to us, and we're trying to find the measurement angle MIL, which is represented here by x. The other angle next to it is 5x. If you look at this right here, this appears to be a straight line, and we're going to make that assumption. If it's a straight line, then it's a straight angle. We know that a straight angle measures 180 degrees. So if we take 5x and put it together with x, that's going to equal 180 degrees. So that's our first step in setting this up. 5x plus x equals 180. These two angles together make a straight angle. When we solve for x, we get 30. Now I'm looking for the measurement of angle MIL, which is this angle here, and it's represented by x. It's 30 degrees. So the measurement of angle MIL is 30. If I was looking for the measurement of angle MIA, I would take 30 for x and plug it into 5x, and I'd get 150. Looking at example number 3, it says if NO is 18, OT is 12, and NT is 30, which point is between the other two? So the assumption here is that these are going to be collinear. Another way I know that is if you look at these two segments here, 18 and 12, together they give me 30. Now the way I go about a problem like this is I start to think about, well, what's the biggest segment? What's all of it together? And NT equals 30. 30 is the biggest one. So that tells me that the points N and T have to be the endpoints. If N and T are the endpoints, the only other point available to me is O. That means that O has to be between the other two. And again, NO plus OT gives me NT. Example number 4, we're looking for the restrictions on EN. So EN is a segment right here, or the segment down here at the bottom. Let me grab the highlighter there. There's segment EN. And we're trying to find out what is it greater than and what is it less than. And what does it have to be between? That's what restrictions means. So we're going to take this segment right here. And there's two things that we have to consider. What is it going to be bigger than and what is it going to be less than? In order for a triangle to exist, the two smallest sides have to add up to more than the third side. So our first assumption is maybe that 8 and that 12, maybe those are the smaller sides and EN is the bigger side. If that's the case, that means that EN has got to be less than 20. Because the two smaller ones together have to be greater than the third side. Well, maybe it's not. If EN is not the biggest side, PN has to be the biggest side because 12 is bigger than 8. PE plus EN has to be greater than PN because, again, PN is the biggest side. So I know that PE is 8 and I know that PN is 12. And when I plug those in and solve, I know that EN has to be greater than 4. So my restrictions are that EN is greater than 4, but it is also less than 20. And that's it for the notes.